So in this class, let us discuss about more on finite differences. I mean, we have already seen what are finite differences: forward difference operator, and the backward difference operator, and the shifting operator. Okay, so in addition to these three operators, I would like to introduce few more operators here. So first of all, let me write what they mean. Delta of yi, you know, that is yi plus 1 minus yi, whereas nabla of yi, that equal to yi minus yi minus 1, and this is shifting operator. Job is shift just by 1 unit. Alright, so these are what the forward and backward and shifting operators. Now let me introduce the central difference operator, delta. Okay, so now this delta, central difference operator, we usually denote like this. If you take delta of yi, and that will be yi I plus 1 by 2 minus y I minus 1 by 2. Means you can understand what is happening here. It means suppose you are on a line, you are a line here, and here you are staying. Alright, so let me assume this is what I. So now to take the difference here, and you be in the center and move one step forward here and one step backward here, then you take this difference. It means you will take the difference between I plus 1 term and I plus 1 by 2 term and I minus 1 by 2. So the step size, the total step size is same. Here also you are taking 1, here also you are taking 1, here also you are taking 1. But here in the forward difference, if you observe that you are standing at I and you are taking plus 1 forward and you are taking the difference. Whereas in the backward difference, and you are taking one step backward and then you are taking the difference. Whereas in the central difference, right, you be in the center, one step, half step forward, half step backward, then you are taking the difference. So that is what is happening. Right. So now let's see what is the relation with the shifting operator with this. So now let me rewrite it in different way also. Suppose if you write delta of y 1 by 2, that will be equal to y1 minus y0. Because 1 by 2 plus 1 by 2, that is 1. 1 by 2 minus 1 by 2, 0. Okay. Now if you want to equate the forward difference operator and the central difference operator, and this is what? So delta of y0 is actually equal to, so I mean this del, you may say, this is the central difference operator acting on y1 by 2, and this is going to be same as the nabla of y1. Okay, so this is how you can relate these three. Now let's have a relation with the shifting operator also, because we already proved that this delta equal to e minus 1, identical equal to e minus 1, and similarly this nabla is identically equal to 1 minus e power minus 1. And how about this central difference operator? And this will be equal to, I hope you can see that it is e power 1 by 2 minus e power minus 1 by 2. Okay, now this is the relation between the central difference operator and shifting operator. Okay, so in addition to the central difference operator, I would like to introduce one more operator, that is average operator. Okay, so average operator, new. So it is there in the name itself. The job of average operator is, if you give me two guys, it will take the average operator. So it is like new. Let's say if you take new of yi, new acting on yi, and it is yi plus 1 by 2 plus yi minus 1 by 2 by 2. It means in the center you are there and you are moving half step forward and half step backward, and you are adding it and you are taking the average of it. Okay, so this is the average operator. And if you express in terms of shifting operator, it is easy to identify that u equal to the nu equal to 1 by 2 into e power 1 by 2 plus e power minus 1 by 2. Okay, so this is the relation between the average operator and shifting operators. And whereas the relation between the central difference operator and shifting operator is this. Okay. Now let us try to explore little more on it. It means now I'd like to derive what is the relation between the central difference operator and average operator. So let us try to explore that.
Sir, please once tell about geometric view of mu I, sir, average operator.
What?
Geometric view of average operator, sir. How is geometry?
Geometric view.
I mean, half step forward, how we take average, we get difference, sir. In central difference operator, half step forward, half step backward, we take like that, sir. In average, how we define like this?
Yeah. Okay. Fine. So if all right. So let me. See, you're at YR. All right. And if you want the average at YR, okay, so it's like the one we are always considering the length one guys only. So from R you move one step forward, that is R plus 1 by 2, half step, not one step. Y R minus 1 by 2, and you're taking average of it. So it is not the difference. You're actually, sometimes we may be interested in the averages.
Okay, sir. I thought it was a difference operator. That's
No, it is not a difference operator. It is average. It is plus.
Okay, sir. Understood, sir.
You can actually get some relation between the difference operators and average operators. Okay, now right now I'm trying to do one. So now the question is, what is the relation between mu and delta? Okay, so let's try to answer this question. What is the relation between these two? So for that, let me do one thing. So initially I have mu equal to 1 by 2 into e power 1 by 2 plus e power minus 1 by 2. And whereas delta, which is e power 1 by 2 minus e power minus 1 by 2. Okay. Now let me forget the expressions and let me think these guys as some numbers only. Like some expressions only. Nu equal to a plus b by 2 and delta equal to a minus b. This is what we have. So now if we want some relation between this a plus b and a minus b, I hope in terms of squares we can obtain. Yeah. Why? Because a plus b whole square and a minus b whole square, they are not equal, but I can say a plus b whole square is equal to a minus b whole square plus 4ab. This I can say. And here a and b, a is nothing but e power 1 by 2 and b actually e power minus 1 by 2. So if I multiply a and b, that is e power 1 by 2 and e power minus 1 by 2. So that gives us e power 0, it is 1. Okay, so now here we just have 4. Alright, now I hope we got the relation. So now this a plus b is nothing but 2 into nu. A plus b is actually 2 into nu. So if I substitute it here, so 2 into nu whole square equal to delta square plus 4. That's it. This is the relation between the shifting operator and the central difference, sorry, um, central difference operator and the average operator. Okay, so let me write it everything clearly. So now what I'll do is, first I'll start with this new, okay, and so I'll take square of it. What is new square? That is 1 by 4 into, okay, so let me take one step, plus e power minus 1 by 2 whole square, and that equal to 1 by 4 into, this is e plus this is e to the power of minus 1 plus 2 into, we can see when they multiply you will see e power 0, that is same as 1, right? Now I hope this one can be expressed as 1 by 4 into, yeah, so this is e plus e power minus 1, and we want e power 1 by 2 minus 1 by 2, so for that I'll do one thing, I'll write it as minus 2 plus 4. Now it is easier to see that it is same as 1 by 4 into, now it is looking like e power 1 by 2 minus e power minus 1 by 2 whole square, okay, plus 4. So this implies we got 1 by 4 into, this is delta square plus 4. So in other words, therefore mu square is equal to delta square by 4 plus 1. So this is the relation between the shifting average operator and the central difference operator. Right. So now I would like to explain some use of this difference operator. We have seen that it can be used in Newton's forward and backward interpolation formulas. All right. Now let us see how to find missing terms in the table using this